Here are all 5 main ways to factor explained in just one video. So here's our first example. We need to factor this polynomial. So we're taking this thing that's already simplified and we're trying to turn it into multiple things being multiplied together. And for this case, we're going to be using something called the GCF. GCF stands for greatest common factor. You probably have heard that phrase in like elementary school or something, but here's how it applies to algebra. Basically, we need to figure out a factor that's in common with this first part here and the second part here. And a factor is basically like, for example, if you had the number 8, 8 can be broken down into 2 times 4. And these are factors of 8. So let's go ahead and look at the numbers first. I'm seeing 4 here and I'm seeing 6 here. Well, I'm noticing that these can both be divided by 2. 4 is 2 times 2, and 6 is 2 times 3. So 2 is a common factor between both of these. So let's go ahead and put a 2 on the outside of our polynomial, and on the inside, we're just going to put the same thing, but we divide everything by 2. So 4 is now going to become 2, because 4 divided by 2 is 2. And we're going to leave everything else the same. And then 6 divided by 2 is 3. B to the third. So we've just factored out a 2. And if you're not sure if you did it right, you can just do distributive property, multiply the 2 to both of these, and you should end up with this top part again. Remember, we're basically just doing the opposite of simplifying. So we're done with the numbers here, right? Because 2 and 3, they don't have a common factor. But actually, we can do the same thing with letters. I'm noticing that both of these, this first part and the second part, they both have a b to the third. So we can factor that b to the third out. So we're going to have 2b to the third. And then we're going to take the b to the third out from both of these. So it's just going to become 2a squared plus 3. And this can't be factored anymore. There's nothing to divide out. So this is our final factorization of what's on the top. All right, here's our second example. We need to factor x squared minus 16. Now, there's no common factor here, right? Only one of them has numbers and only one of them has letters. So we're not going to be able to do it that way. But I am noticing that these are both perfect squares. 16 is a perfect square because 4 times 4 is 16. A perfect square is basically any number where you can multiply 2 of the same number to get it. So 16 is 4 times 4. And x squared is also a perfect square because x squared literally just means x times x. So because these are both perfect squares and because there's a minus sign in between, we can use the creatively named rule, difference of squares. So difference of squares basically says that if you have a squared minus b squared, this is basically just saying we need to have a perfect square on the left and a perfect square on the right with a minus sign in between. If we have this, then we can replace it with a plus b times a minus b. So what are a and b in this case? Remember that because this is a squared, not just a is not going to be x squared. It's going to be whatever we multiplied twice to get to it. So we'll actually look at the 16 first because I think that'll be easier to understand. Remember that 16 is 4 times 4. We multiplied 4 twice to get 16. So b is going to be 4. And in this case, to get x squared, we multiplied x times x. So a is going to be x. So a is x and b is 4. So in this thing that we're replacing it with, all we need to do is replace a with x and b with 4. So instead of a plus b, we're going to have x plus 4. And instead of a minus b, we're going to have x minus 4. And this is our final factorization. This is us factoring x squared minus 16. All right, here's our third example. We need to factor x cubed, that's the word for x to the third, x cubed plus 27. Just like before, there's no GCF because this just has letters and this just has numbers, so we're not going to find something to divide out of both of them. And these are not perfect squares because 27, there's no way to get 27 from like multiplying 2 to the same number unless you use decimals, but no one cares about decimals. But 27 is a special number because it is a cube number. It's not a square number, but it's a cube number because you can multiply 3 of the same number to get to it. You can actually multiply 3 times 3 times 3 to get 27. And x to the 3 is also a cube because you can multiply x times x times x to get to it. So we can use another rule that's just as creatively named as the last one. It's called sum of cubes. Now I actually have an entire video on sum of cubes and difference of cubes. So if you're not familiar with this, you can actually watch that video that's on the card on the screen. but I'll go over sum of cubes because that's what we're going to be using. You would use difference of cubes if you had a minus sign, but we have a plus sign. And because of that, we're going to use this rule. Just like before, we're going to have that format of a cubed plus b cubed, but this time it's going to turn into something a little more complicated. It's going to turn into a plus b times a squared minus ab plus b squared. So we need to figure out a and b just like before. In this case, b is not going to be 27. It's going to be what we multiply 3 times to get 27. So 3 times 3 times 3 is 27. B is equal to 3. And in this case, we multiplied x times x times x. That means that a is x. So whenever we see a, we're going to replace it with x. And whenever we see b, we're going to replace it with 3. So a plus b is now x plus 3. And now a squared, that's now x squared, minus ab. There's no sign. That means multiplication. So this is actually a times b. So that's x times 3. You can't multiply a number and a letter, so it's just going to say is x times 3. Or we'll put 3 times x, because numbers usually come before letters. And now plus b squared, that's plus 3 squared. 3 times 3 is 9. And that's it. We have now factored x cubed plus 27. All right, here's another example. We have x squared plus 5x plus 6. No, there's no GCFs we can get out of this, and we can't use the rules from before because those were only when you had something plus something or something minus something. But in this case, we have 3 different parts here. But this may look familiar to you, and that's because if you have 3 parts, one of them has x squared, one of them is x, and one of them is by itself, this is actually in quadratic form. Now, this is another form that I actually already have a video on as well. So if you want to watch that video, it's on the card on the screen, but I'm also going to go over it here. So to factor a quadratic, because we don't have a number in front of x squared, we're going to use the easier version. If you had a number in front of this, you would have to use the x method, and in that video that I put on the card like 10 seconds ago, I go over the x method in that video, but we're going to be using the easier version here. And all you have to do is figure out 2 numbers that add up to the number that's in front of x, so they add up to this, and multiply to get the number that's by itself. So I usually think of numbers that multiply first and then see if they add. So numbers that multiply to 6, well, we have 1 and 6, right? Because 1 times 6 is 6. But if we add these together, we get 7. And that's not what we're looking for. We want 5, right? But 2 and 3 also multiply to get 6. And if we add these together, 2 plus 3, we get 5. And 5 is the number we're looking for. So 2 and 3 are our final numbers. So this is going to look very similar to the other things we factored. We're going to have things in parentheses. We want it to be in this format, x plus something or x minus something in parentheses. And we're going to put in those numbers we just found. Those were 2 and 3, so that's going to be plus 2 and plus 3. And if they were negative numbers, you would put minus instead. And there we go. We have factored this quadratic. So here's the final thing we're going to be factoring in this video. And wow, that is a long one. For this one, we're going to be bringing back some of the things that we did earlier in this video. But you might be thinking, how are we going to figure out anything to do with all 6 of these? Well, for this, we can actually break this into smaller chunks that we can factor. And this is called grouping. Now, grouping is one of these things that you might be asking yourself, like, how did you even figure this out? How did you know how to do this? And honestly, it's just a lot of trial and error. Just experiment with the numbers and see what you can figure out. But the thing that a lot of textbooks do is they'll have something that looks like this. The problem itself will have 4x squared plus 3x squared. And you might be saying, well, can't you just combine these? Because they both have x squared. This is just 7x squared. But normally, if the problem has something like this, if it splits it up, it's probably splitting it up for a reason. So what I'm going to do is I'm going to group this up into this section and this section. And the reason I'm grouping these up is because these all have GCFs that we can factor out. So in this case, we don't have a number we can factor out because this doesn't even have a number in the first place. But we actually have 2 x's in each of these. So we can factor out 2 x's out of each part. So we're going to have x squared times, and then we're going to rewrite this, but we're going to take out 2 x's. So here we had 4 of them, now we're only going to have 2. Here we had 3x to the third, now we're just going to have 3x to the 1. And then here we had 4x squared, we're taking out an x squared, so we're only going to have 4. Now we're going to put a plus sign, because there's a plus sign here. And what GCF can we take out of this group? Well, we can't take out any amount of x's, because this doesn't even have an x over here. But we can take out a number. These can all be divided by 3. 3 is 3 times 1. 9 is 3 times 3. And 12 is 3 times 4. So we can take out a 3 out of each of these. So we're going to put a 3 on the outside, and then we had 3x squared. We're taking out the 3. Now we only have x squared minus 9x. 9 divided by 3 is 3, so that's 3x. And then plus 12. 12 divided by 3 is 4. And you'll see that now we magically have the same thing in parentheses on both sides. If you're wondering how that magically happened, it's because the textbook writers wanted it to happen. But the problem might not already be in this order. You might have to move a couple of things around to get the perfect groups. So it's going to take a lot of experimenting, but just try to group together parts that can have a GCF that you can take out. So because we have the same thing in both of these parentheses, we can actually combine these. And this is basically the same thing as doing combine like terms. So if we imagine x squared minus 3x plus 4 all is just one letter, we can combine these by doing x squared plus 3. So we have x squared plus 3 times x squared minus 3x plus 4. I know it seems confusing why you're able to do that, but let me just illustrate with, for example, if you had 4x plus 5x. If you have two of the same variable, you add together what's on the outsides. So 4 plus 5 is 9, you would get 9x. And this is just a more complicated way of saying the same thing. We have the same variable, which is just one big long thing. But because we have the same ones on both sides, we add up x squared plus 3. And then the variable, in this case, this big long thing, stays the same. So this is our final factored form of what's up here. So now you know all of the main ways to factor. But a lot of those things I showed you, like the sum of cubes and the difference of cubes, you might be wondering where that even comes from. Actually, you probably weren't wondering that, but it's okay. You're probably going to have to know it anyway, because you're going to have to eventually prove that these are true identities. So if you want to learn how to prove identities, you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments and I'll be sure to answer your question. Thanks for watching.